All right, so my presentation is UAP warp drive signature detection, and I'm detailing 5 new observables. These are on top of the original 5 as detailed by Luis Elizondo in his book, Imminent. I am a volunteer member with the Center of the Scientific Study of Atmospheric Anomalies, or CISA for short. It was started by a fellow named Rob Freeman. One of his famous videos is an orb that was filmed in Squamish, British Columbia, not far from where I grew up, actually. So we have the original 5 observables, not including the bodily effects: anti-gravity lift, hypersonic velocity, sudden acceleration, low observables, and transmedium travels. And in my book that myself and my co-author, Professor Dave Palachuk, published earlier this year, we've identified gravitational lensing, leading edge vapor cones, oscillation blur, gravity counterbalancing, low velocity disk, flight configuration, and saucer-like skipping motion. So gravitational lensing is where, as the UAP is moving in front of an object, the background gets momentarily deformed or warped. The center image is an animated recreation of a black hole passing in front of a galaxy, and on the right is a photo from the 1950s showing a UAP in and of itself being affected. Leading edge vapor cones is something new no one ever expected, including myself. I first noticed it in the Aguadilla UAP video, and then I found another video from 2023 showing the leading edge. Oscillation blur is where a UAP is turning its warp drive on and off rapidly for various reasons. Counterbalancing is when flying at a low speed, a UAP has to counteract Earth's gravity and provide forward momentum, so it will fly tilted, similar to how helicopters fly tilted. And saucer skipping motion is where a disk or some other UAP is flying horizontally, but it's moving up and down like a saucer skipping across water. So a little housekeeping information. This presentation is solely the opinion of the presenter and does not represent the opinion of past or current employers. Fair use notice: some of the videos, photos, and artwork are for educational purposes, and at no time did I ever receive any classified information for creating the content. I have published 1 book, and I have a second book, Missing Time 2, about abductions, coming out mid-summer. And what started it for me was this video. I found it on the Angry Astronaut podcast, and it was a Saturn-shaped UAP flying in front of clouds, and I noticed the background objects were moving. I called my friend Dave and said, take a look at this. Do you see them? And he says, yes, I do too. And this is where our research started, right here on this video. But to give some background context about gravitational lensing, let's first dive into the Alcubierre shape function. So that's his formula at the bottom. I created a scatter plot using Excel. So what it does is it shows, you take a point in space, you put it into the formula, and it tells you how far away it pushes that point of space away from the center of the warp drive, or in the case of the upper part, pulls it towards the center of the warp drive. Now there's 2 downward pointing arrows. I will explain those in a minute. But let's first describe what is gravity. We need a simple explanation so everyone can understand. The best I ever heard was take a block of wood, drill 2 holes through it, thread some strings or rope through it, tie it to the end of a doorknob, and then pull it apart. That block of wood will move away from you and towards the doorknob. The doorknob represents Earth. The block of wood is any object in Earth's gravity, and the strings represent the spatial warp. We all know that large objects warp space, and it creates this lever effect where every molecule in your body is simultaneously applied this lever effect, pushing you down towards the ground. That's how gravity works. So this in mind, on the left-hand side, the Alcubierre warp drive actually has two backwards or downwards facing V shapes. So there was a disconnect between the upper and the lower hemispheres. I had to create and find an elastic formula that's down in the center, and it allows the upper and lower hemispheres to curve back towards each other. It is in that spot, in this wine decanter shape, where an object or a vehicle can exist and will experience upward or forward gravitational acceleration. If it's anything below it or above that area, will either be pushed down into the top of the disc or pulled off the bottom and pulled away. And because this is a circular wine decanter, if you're going to build a vehicle with the maximum internal space for engineering space, cargo space, passenger space, scientific study space, you're going to want to build it as a disc-shaped object, which means it is absolutely no accident that UAPs, by the vast majority, are disc-shaped for medium-sized UAPs. Now, this is the next part of this and the final part of the scatter plot. I've applied a compression color chart to it. So the warp bubble is round, but inside where it counts is wine decanter shaped. But you can see here in magenta, just above center, is the high compression zone, and red below that is the expansion zone. Now, let's get into what is gravitational lensing. So here's an example from astronomy. Between the Earth and a quasar far off in the distance is a galaxy. The galaxy is going to pull space in towards itself as light travels from the quasar, which the light normally going away from us gets bent back towards us. And what you see on the right is an Einstein ring. You can see the center of the quasar in 4 different locations. Now, at the macro level, instead of astronomical level, if a UAP, in this case a dark cube, is warping space as its form of propulsion, light passing through that curved space will also bend slightly. And in this case, the same pattern occurs where light going above and below are bent back towards an observer. The observer is going to see, on the left, a dark cube inside a round sphere, a transparent sphere. It's not a real sphere, it's an Alcubierre warp sphere. So it's not glass, it's just spatial bending causing the light from the background to appear as if it's in a clear sphere. All right, there are 3 types of gravitational lensing that I've identified: momentary background deformation, radar return echoes, and deformation of the UAP body themselves. So the Aguadilla UAP video was first identified as having gravitational lensing by Kenneth Knuth, and I found his slides from a presentation back in 2021. In this particular spot, the object was passing in front of the tarmac, in front of the lines, the painted lines, and you can see row A is the original FOIA release video. Row B is a computer enhanced contrast and denoised. So you can see the background lines are actually momentarily disappearing or warping as it moves in past. The next major one is as it's passing in front of this building, which is dead center of the screen. Column A is the original FOIA, column B is contrast enhanced FOIA, and column C is a computer enhanced and denoised. And in the dead center, and over here, you can see as the UAP is traveling in front of a linear feature of that building, it actually curves down. The building curves down momentarily. And you can see it a little bit better here. And this spot here in B looks exactly like the gravitational lensing simulation we had seen earlier. Now, there's this argument that it was a object, balloon, or sky lantern in parallax. But here, there's a set of trees. You can see it passing behind in the animated GIF. And there's another blown up example of it changing the background as it moves past and in front of. There's a dark line feature that clearly deforms. So Arrow in November 2024 had said this was a balloon or sky lantern. Well, what do balloons look like to an IR camera? A fellow named James from James Drones Thermal had presented his finding. He took an IR camera, put a latex balloon out, and you can barely see it, and that's with the camera 5 feet in front of the balloon. And there's two different color formats, B and C. Now, Dave Felch had done another experiment where he released a latex balloon and filmed it using the same camera that was on board the Department of Defense aircraft over Aguadilla. And the little red arrow points to where the balloon is, but if you didn't point it out, you wouldn't be able to see it. Now, another type of balloon is mylar balloons. This is the other type. It's an aluminum, and it absolutely reflects everything around it. It's a perfect mirror in IR. Mick West was attempting to debunk the rubber duck video, as you can see on the right, saying that when filmed from above, he filmed this from his balcony looking down on this happy birthday balloon. And the balloon looks cold because it's reflecting the cold sky. And there's a small part underneath it where it's on the underside it's reflecting the lower ground. So a mylar balloon would appear cold as a bright white, not hot. Now, the other option was, the other thing they said it could have been was a sky lantern. Dave Felch also filmed a sky lantern, tied it down to his driveway using an IR camera. You can see this dark blob. This is the closest thing to what the UAP, the Aguadilla UAP, looked like. However, there's an anomaly issue. I've identified as the object passed in front of pretty much every darker background, it displayed this cold cloud, either in front of or above and trailing. And at first I wasn't sure what it was, but I realized later that it was a vapor cloud being formed. So because Arrow said it was either a balloon or a sky lantern, they didn't bother looking at what do latex and mylar balloons look like, which means they did enough work to confirm what they thought it probably was, which means they were falling for confirmation bias. I won't read this. Anyone can pause this and read it if they feel like it. But it's especially important to point out people are especially likely to process information to support their own beliefs when an issue is highly important or self-relevant. Now, there is one other argument that has been used to debunk the Aguadilla, and that is when an IR camera is filming an object and it's zoomed out, you're going to see this white line and a dark outline, or inversed. In this particular case, white is hot and cold is black. And the closer or the more the camera zooms in, the more clear this object becomes. Now, the same thing happened with Aguadilla. The first two images, A and B, were filmed at a distance with it not magnified. The value of 135 was the magnification. You can see the dark round object with a white outline, and there are some objects on the ground that are also dark with a white round outline. However, when they zoomed in to magnification 675, the closest it came, you can see in number C here, or letter C, it was just pure dark black, no outlines of any kind. And D, as it passed in front of a road, you can see that there's this cold area forming behind it, like it's leaving a trail of vapor behind it. This does not look like this. So this argument that it was a pixelation issue goes away because they did zoom in, and they zoomed in enough to identify with detail. So what are leading edge vapor cones and how do they work? So this is a zoom in of the Aguadilla. I color coded it to emphasize what is hot and what is cold. And you can clearly see this vapor cloud forming in different locations. So essentially what we need to understand is, going back to that spatial compression above the UAP, let's use a simple example, the TARDIS from Doctor Who. It's the size of standard police blocks, 192 square cubic feet, but the interior is at least 10,000 cubic feet in size. So this is a relative thing. When a volume of space is compressed, the interior of that volume still maintains its original size. However, to an outside observer, the volume of space and its contents will appear much smaller. Now, if the door was left open and a speed wind of 100 miles per hour blew into the TARDIS, the air would find itself in a much larger volume of space suddenly. This would cause rapid decompression. When air is decompressed, it cools rapidly. Cooled air causes vapor to condense, and condensed vapor forms visible clouds. So this is a diagram of what the Aguadilla UAP was doing. As it was traveling, its spatial compression was above and slightly left. That spatial compression was moving through the atmosphere at about 100 miles per hour. Air that was in a pocket of space, let's say 1 cubic foot in size, suddenly finds itself in an open space of 100 cubic feet. It'll rapidly decompress, creating a vapor cloud. It's kind of similar to the vapor cones you see on aircraft when they're traveling between 0.8 and 1.2 Mach, but instead of being behind the craft, it's actually in front of the craft. So I'm not the only one to spot this. The Skywatchers recently have released some of their videos, and they noticed it as well. And they stated it appears there are some kind of cloud or vapor around it. And they shared one example of it, but in an interview, one of their leaders was saying they had seen it in multiple videos. And then this is another example that came out just last month. It was filmed in Perth, Australia. And there was this glowing green-blue orb that was flashing on and off, leaving a vapor trail behind it. Everyone was looking at it, commenting what could be, but since leading edge vapor cones was not known publicly, everybody was absolutely clueless as to what it could have been. Okay, there are then radar echo returns. So we have been talking with the Tedesco brothers, and they have been using their Nightcrawler Mobile Research Lab. They were able to identify and record 14 examples using radar and video or photos of long echo delays and unexpected field echoes. This is another form of very solid evidence, but it's going to be hard to debate exactly what it means. So here's an example on the right of one of the radar plots. So I've circled the boat lower center, and there's a second boat showing up at the extremities at the top. The boat's showing up twice. Why is it showing up twice? The reason is gravitational lensing. The radar sends out a signal A, which bounces off the boat B, which spreads as it comes back. It comes back normally along path C, but it's going to bend around the spatial compression around the UAP, which is above and between the radar and the boat. So it's either going to bend below and or above through the spatial warp and back down to the radar. Basically, the radar sees the return twice. So it plots it twice. Now there's a second plot on the right-hand side circled in E. This is what they call a long delay echo. This was approximately 1 second of returns. Now, just so everyone knows, each radar device sends its own coded signal out so that if two or more radars are tracking the same object, they don't confuse themselves. So it's receiving its own signal back multiple times along E, path E, and C at the bottom center is where the UAPs were located in this photo. So we're not exactly sure why it was receiving it multiple times, the same signal back. One possibility is that the echo returns were somehow orbiting or being caught up in the UAP's spatial warp and then returning to the radar. Now, this is, we need to go into field calibration, because this is something that skeptics will ask is, how about calibration? Was it calibrated? The answer was yes. On the right-hand side, they actually went out, found a buoy at sea. Now, buoys have a transponder on them. When they receive a radar, a marine radar, they'll record that code and send it back multiple times. So you see this long track on the right-hand side in image C. This is done to highlight the fact to a captain of a boat that there's a buoy out at sea, please don't hit me, is essentially what it's saying. Because otherwise, it would be a small blip, it would be barely noticeable. Now, here are several examples. The bottom right is the buoy example, and the top right is another example taken. The quote on the left is from their paper, but essentially this UAP was returning multiple blips, and it was intermittent blips over a period of, it was a short period of time, but it was multiple returns. In this particular case, they had actually pointed the radar up away from the sea, and this is one possibility that might explain why it was seeing its echoes return multiple times. Again, the radar may have got caught up in the spatial warp and then returned multiple times. So this is an example of the buoy versus the UAP. There is a distinct difference. Now, why could radar waves get caught up in a warp bubble? This is one possibility. There's another one I'll explain in a minute as an alternate explanation. But light is a high energy and a small electromagnetic wave, where radar is low energy and a large electromagnetic wave. So it's the combination of the low energy and the large wave could allow it to orbit around in the warp bubble before it escapes. So is there another explanation? There is, but let's first examine the 2004 Tic Tac incident. Commander Dave Fravor noted in a podcast, there is a little signal that shows up in both the images. The left is the visible light camera, and the right is the infrared camera. 99.9 range 99 was the signal error message he was describing. This message is very clear and distinct. This says that the radar is receiving multiple pings back, which is typically, and the other thing that we did not get from the release was the radar plot. We only have the video, we do not have the radar plot. Typically, this 99 is when someone's actively jamming, which is going to look similar to the radar return of a buoy. Now, why is that the case? Well, if you don't want to be shot down and you're an adversary and a radar signal gets sent out, A, hits your aircraft, B, your aircraft records that radar ping and returns multiple of the same radar pings in C. What that does is your adversary cannot tell how far away you are. And that's important because radar-guided missiles don't actually strike the aircraft. They blow up beside it with shrapnel. That's how they take them out. So if you can't tell what the range is, the missile can't strike you. Now, possibility number one with the Tic Tac is A, the radar gets sent out. B, the radar ping arrives at the UAP, but because of the spatial compression above and below, the space is different. So the upper section is a shorter path than the lower section of the spatial compression and expansion, so it returns earlier. So C, you get 2 returns back. So the computer might have seen 2 returns and go, oh, I'm being jammed, and give the signal, give that error message. Possibility number 2 is the radar signal comes out, the spatial warp and orbits around, and you have multiple returns coming back, similar to what was shown with the Tedesco brothers radar plots. Possibility number 3 is the Tic Tac received the radio signals, recorded them, and returned them back because it didn't want to be shot down by a radar-guided missile. That's a big leap, and it means something really intentional. What this means is all 3 possibilities, irregardless of what they are, means that if any one of these is true, the Tic Tac was a manufactured object, manufactured by someone with intelligent design and an intent to, in the case number 3, intent to keep a radar from detecting exactly where it is in the sky. Now, debunkers, and Neil deGrasse Tyson was the first to say this in a podcast with Joe Rogan in 2021. We don't even know if the Navy calibrates its sensors the way we calibrate telescopes. Well, is there a calibration issue? That's what he's saying. The answer is we do know. Declassified manuals published online. He never bothered to look them up. The 99 error message is a hard code failed value indicating that it has received multiple returns of the same code it sent out. This is not a possible calibration issue. Some other error message would have come up if it was a calibration issue. This is clear and distinct. It is receiving multiple returns from its radar pings. So, how does calibration work within the Navy? Aircraft radar is calibrated when it's turned on. It takes 2 or 3 minutes when the aircraft is turned on. The at-FLIR pods are calibrated every time they're turned on. Shipboard radar, they are calibrated daily, multiple times a day. Why? Because people's lives literally depend on these functioning systems. If radars don't work, people are not going to make their way back to the aircraft carrier, and they will have to ditch and sea, or some other catastrophic event could occur. So Neil deGrasse Tyson had, I want to bring this up and point this out, he'd chosen to debate creationists defending evolution. Now, when he wrote about that, he said, the good thing about science is that it's true whether or not you believe it. The thing about the Navy and their calibration is, the good thing about the Navy is that it diligently calibrates whether or not you believe it. And the other thing he wrote was, check your facts before making claims. Neil did not check his facts before he made his claims. All right, gravitational lensing number 3, deformation of UAP bodies. The earliest photo I could find showing deformation was Hopei, China, 1942, long before we even knew what UFOs were. You can, in the blow-up, you can clearly see the left-hand side of this disc is pushed in and upwards. There's a 1952 photo from Passaic, New Jersey, taken by George Stock. It shows here, there's 5 photos, I'm showing 2 here. A on the left, and I've blown it up for C. You can see here clearly that the upper dome is tilted and offset to the right, and then also the disk itself is thicker on the left and thinner on the right. And then for comparison, when the disk is tilted away instead of perpendicular, it is symmetrical. And there's a reason for this. And I'll get into that. And it's got to do with low velocity tilted flight. So here's an example from Rex Heflin, 1950 photographs. You can see it on the right-hand side. And the reason why it's tilted is to do with the flight control. What I've taken here is on the left-hand side, A is the Alcubierre warp drive, and I placed a smaller warp drive inside and below the larger warp drive. And what it did is it increased the warp field on the left side, which will cause it to tilt and move up to the right. So in sample C, that expanded warp on the left-hand side will allow a UAP to counteract Earth's gravity, yet still have a slight forward momentum to the right. So this is exactly how it would function, exactly the same as a helicopter at approximately the same speed. And you need at least 3 smaller warp nacelles inside the major warp nacelle. Now, there is a paper that was published on the discovery of micro warp bubbles. Now, the paper shows that someone has actually created an actual functioning warp drive, but it was at 4 micrometers in size. So they proposed the next step was to create a daisy chain and see if it would increase the warp signature. So lower left is the a plot output showing that when you do add them together at a very close distance, the warp bubble does increase in size, but its strength decreases with every additional one added. However, in C, top right, if you create multiples of these warp bubbles in a cone shape, not only does it increase in size, but the steepness of the warp increases as well, which means if you turn on and off the outer warp bubbles in this configuration, you now have throttle control. So how does this work? If you create a large cone shape of micro warp bubbles, a couple of billion inside of something, let's say 6 feet tall and 6 inches wide, you could put that in the upper part of a disk. Now for flight control, as I mentioned earlier, you're going to want 3 smaller ones down below. So you put them underneath on the underside of the disk, and now you've created not only micro warp nested bubbles, but they have macro warp nested bubbles. So you turn all 4 on. The lower ones you turn on slightly. It creates a warp bubble that encompasses the entire craft. And then for flight control, you would adjust the lower ones up and down in strength to increase your speed or tilt and essentially achieve your flight control. Some people may see this and recognize this particular configuration of warp nacelles. And that's because this is Bob Lazar's sport model, how he drew it up, how he diagrammed it. What I've basically shown is Alcubierre's math shows what Bob Lazar reported is correct and accurate for that theory. The difference is he used waveguide and gravity amplifiers. The reality is all 4 are gravity amplifiers. So tilted flight control using nested warp nacelles, using the sport model configuration. You can see here on the left, Paul Trent's photo, tilted. It is in line with the camera. I've placed the warp bubble and the scatter plot over top of it. You can see down here, center line is here. This protrusion up the top is actually the central warp nacelle, And because there's two spatial contractions above, the light from that warp nacelle is being bent towards the left and leaning slightly. And you can also see a slight bulge on the lower right and a slight compression of the disk on the upper left. Same thing with Rowan photos from 1953. It's similar, if not identical craft. It's a little bit of a more detailed. The upper warp nacelle again is tilted and even farther to the left, and then you can see a bit of a bulge on the right versus the left. The Trinidad photos from 1968 also show the same thing in 2 of the 4 photos. Every photo shows tilted flight. However, A and B show a compression on the right-hand side and an expansion of the disk on the left-hand side. C and D shows that it's symmetrical, which means that it was probably descending at the time and it was not creating an asymmetric but a symmetrical warp bubble at the moments of those photographs. Now, some debunkers say this is proven hoax, this thing, but it's not. Some 50-odd people, I believe it's 48 people, all witnessed it. It was investigated by the Brazilian Navy and for 2 years, and they concluded that it was not a hoax. All right, so we have a new observable benchmark, the Heflin standard, I'm calling it. Now, he took 4 photographs. There have been a couple of papers evaluating his photos. The craft was always blurred, yet the background objects like the telephone poles were crisp and clear, and they did not know why. The reason is warp oscillation. And just straight looking through the warp bubble itself will cause a slight blur. But if the warp system is turning on and off rapidly, you're going to see it more than once. And then the lower right-hand side, there was a smoke ring that was photographed and the 4th photo, and no one actually understood why until I realized this was a vapor cone that was split as the UAP passed through it as it was rapidly departing. Now, I know there was oscillation going on here because in the 3rd photo, it's not a duplicate. It looks like a double exposure, but it was a Polaroid camera, which is not capable of creating double exposures. So highlighted in green is the UAP in its original configuration not being affected by the spatial warp bubble, and then highlighted in red is this drawn out, warped, smeared version where it is being affected by the warp bubble. The photograph was taken and the aperture was open long enough that the warp drive switched from on off during the capture of that aperture opening. So why would there be warp oscillation? Well, think of it this way. If the object looked warped to the camera, the pilot inside is also going to see the world looking warped. So if he's looking out the window and the warp drive is off, it's going to look like it is to the left in A. But if the warp drive is on, space is going to be compressed and everything's going to be shorter, and he's going to see more sky. Now, this is really important as a flight safety issue. If you oscillate the warp drive on and off, say 30 times a second, and you're using a camera instead of actual ports, you can turn your camera on and off alternately with the warp drive so you can see the outside world in real unaffected space, and you don't have to worry about, am I pointing the correct direction? So if this was hoaxed, how did Rex Heflin know about Alcubierre's warp drive theory back in 1965? And how did he know to create a smoke ring that wouldn't be identified until the publication of my work in 2025? So here's another example of warp oscillation, and this is that disk from Saturn-shaped disk over Columbia. On the left-hand side, you can see there's an edge of the cloud that is moving every other still image, every other still frame. And on the right-hand side, there's an upper anvil that is moving every other frame. Now, there's a couple of possibilities. They may have been oscillating to view the aircraft to avoid a collision, or it might be a stabilized autopilot function. Gyroscopes would not function in a normal, well, I understand say normal, in an Alcubierre warp drive system. It would be screwed up by that. So if you turn it on and off and you use the gyroscope during the off segment, that'll give the computers the real world orientation. So it may have just been autopilot that was identified here. So the last one, saucer-like skipping motion. Kenneth Arnold, June 24th, 1947, saw 9 discs or disc-like shaped objects. In this case, he had it drawn up, looked like a boomerang, but he described them as saucers skipping on water. And K4 Oklahoma News in February 2025, by sheer happenstance, they had a webcam looking out for the weather, and a disc was, or a yellow object was seen moving across the sky in this, and I traced it here in this odd pattern. And the weatherman actually walked up and pointed it out. Now, they did have some quote unquote experts look at this, and for safety's sake, they said, for comfort's sake, they said, don't worry, folks, it's not aliens. Well, we can't tell who's in that, but what we can say is that was an Alcubierre warp drive system. And there's a reason why these craft would move up and down like that. And I'll go over that in a little bit. So another example is the MD Ridoy video posted on Tic Tac in 2023. It's showing gravitational lensing, a leading edge vapor cone, and saucer-like skipping motion. So the video, I've compiled it here on the left. It not only moving left and right, but it's also alternating up and down in descension. So this is the video here. What I like about it is a passenger is pointing out the aircraft, and the other passenger, the camera operator, puts his cell phone up and he records this. Now you can see the camera is moving around. It's not stable. And right there, the disc zips off at a high speed. So I've stabilized it and enlarged it. And on the left-hand side, you can see it a bit better now, and it's a nice stable image, and you can see it's moving across. I'm going to zoom forward, and I'm looking specifically for background deformations. Here we go. So you can see down here, the background is deforming as it's moving in front of. There's a bit here there it moves back and forth, and there's a bit here where it's also moving back and forth. And then this is an interesting part. This area here, this background landscape feature, is momentarily blurring as it moves back and moves in front of it. So that's a deformation blur. Now, this is important, and this is where the last bit, the vapor, leading edge vapor cone appears. It's as it departs at a high rate of speed. You can only notice it when it's on a frame-by-frame basis, or when you really, really slow it down. When I first saw that, I realized that is a vapor cone. And that vapor cone looks exactly like the spatial compression that I previously plotted in the color map. So I've blown up the color map, placed a disk of the same shape and size on top of the color map, and you can see there's a 1-to-1 correlation between the theoretical spatial compression and the photograph and the video still image of the vapor cone in front of the UAP. This was filmed 2 years ago. Nothing was ever published about leading edge vapor cones. How did the videographer Ridoy know to fake this? And when this was filmed, a lot of people responded, "Oh, it's good CGI. It's great CGI." But like I said, the background is deforming. If you're using something like 3ds Max, the background doesn't deform. You intentionally have to deform it using what's called a helper object. If you're using a video game render, those will accidentally deform background objects. I discovered that in a video online. But in this particular case, this is not a lens flare. You can see the lens flare in 3 spots. There are 2 spots on the left, 3 spots on the right. This is detached from the craft. It's not a lens flare. So how does this work theoretically? Well, if it takes all of its, if the disk takes all of its nested warp nacelles, tilts them horizontally into a cone shape and turns them on simultaneously, it will create a warp bubble perpendicular to its disk, and it will fly off at a very large rate of speed. So again, if hoaxed, how did MD Radioy know to fake the leading edge vapor cone? So now we're going to get into some of the work we've been doing with CISA, which is how to detect in the field gravitational lensing. Normally you take a laser pointer and someone would circle it around a UAP in the sky to point out to others. However, when that was done, I found a couple of videos where the laser pointer is actually bending. You can see it here. C, it's bending in one direction, and in D, it's bending in another direction as it's pointed on the other side of the UAP. Contrast enhanced, you can see a little bit clearer, but it's clear. This laser pointer, this laser beam is being momentarily deflected. Now this is an image that CISA took. Again, a laser pointer was on the other side, and in A, the light passing behind was bent down and it shows up around. In B, the light has disappeared from around it, and that light is actually being deflected away from the camera by the Alcubierre warp bubble. So how do you do recommended repeatability field testing? Take at least 2 laser pointers, point them steadily on the other side of a UAP, and let it pass in front and try to detect if the laser is being momentarily deflected. That's one option. The option 2 is take the laser pointer, and you need to have it, the camera operator cannot use it. You need a third person or second person off in the distance, preferably perpendicular, and try and wave that laser pointer through the lower warp bubble underneath the UAP. Don't do it above, because if it's a helicopter, you could blind the pilots, but do it below. If there is a warp bubble there, that laser will momentarily actually not just deform, but actually deflect and change direction. Depending on where it goes through the warp bubble, it'll either bend down or bend up, and that will be a definitive result showing that there's deformation happening to the light. Now, there's another example that I'm recommending as well, taking the radar that the Tedescos were doing and add in a passive radar system, but tilt all of the antennas vertically so that you can then recreate a 3D plot of the radar. So what they were seeing plots out X and Y, but if they had this as well, they would actually then be able to identify the elevation that the radar was returning along. Now, flight safety considerations. We need to think about this when it comes to zipping off at a high rate of speed. Remember back when I was describing if the warp drive is on, everything's compressed, and it looks like you're looking up at the sky, but in reality, you're looking down towards or pointing down towards the ground. So if you think you're pointing up and you accelerate off at 3,000 miles per hour, and you would zip off up into the sky. Now, however, what if you're actually pointing the craft slightly downwards and you turn it on and you zip off at 3,000 miles an hour? This is a mistake. your craft is going to hit the surface of the ground at a very shallow angle. You're going to create a very large debris field, probably a couple hundred feet wide, probably at least 1 to 2 miles long, and you're going to skip off that ground and you're going to fly a few hundred miles or 100 miles or so and land again somewhere off in the distance. This is a plausible, reasonable hypothesis why the Roswell crash happened. If they thought they were pointing up slightly and they accelerated at 3,000 miles per hour and struck the ground, they would leave that debris trail just as was described in the Roswell incident. And that is my presentation.